Assalamualaikum warahmatullahi wabarakatuh. And hello, my name is Amirul Ashraf from SB1, and this is
Muhammad Ikmal bin Arif, also
uh,
from SB1.
yes. Then now we are presenting the question one that was given for us to answer. And for introduction,
Okay, as we know, hydrocarbons are the compounds consist of carbon and hydrogen atom. So here we know that are divided into two types, which is saturated and unsaturated hydrocarbon. So here we will focus on unsaturated one, which is we call as alkene.
yes, algae.
Uh,
So let's continue. So this is the question that was given for us. So basically, this question told us to identify the X, Y, Z and its reaction and observation. So let's go to the answer that we conclude. So from the question one, we are able to identify that the reaction is about oxidation of alkene. So there are two types of reaction of oxidation of alkene, which is for the first one, it will react with cold dilute alkaline potassium permanganate. So we conclude that the hydrocarbon X is 2-methyl pentoene, and for the reaction 2-methyl pentoene will react with potassium permanganate in presence of alcohol in cold and dilute condition, and it will produce 2-methyl pentan 2,3-diol and also mangan oxide. So from this we can observe that the purple color of KMNO4 is become colorless, and brown precipitate of mangan oxide is formed. So for the second reaction of oxidation of alkane, which is it will react with potassium permanganate in hot, acidic and concentrated condition. So for the reaction, 2-methyl pentoene will react with potassium permanganate in hot, acidic and concentrated condition and will produce two things, which is propanone and aldehyde. And this aldehyde will undergo further reaction of oxidation and become propanone acid. And from this reaction, we will observe that the purple color of solution turn into the colorless. So for the conclusion for question one that was given, which is it asks about X, Y, and Z. So for X, it was 2-methyl pentoene, Y 2-methylpentan 2,3-diol, and for Z is propanol. So we will move to next question.
Alright, next we proceed with addition of HBr to alkenes in the presence of peroxide. This one will follow the free radical mechanism. Okay, here we have reactant 2-methylpentoene react with HBr with the presence of peroxide, and this one will form two product, which is major and minor. For major, this rate for major will follow anti-Markov-Nikel rule, whereby hydrogen atom of the electrophile should be attached to the doubly bonded carbon with less number of hydrogen atom, and for the minor, vice versa. Okay, we can here we look at the carbon atom with the double bonded here, which is the third uh, the third one with higher have one hydrogen, while the second there is no hydrogen bonded directly. So for because this one follows anti-mechanical rule, so the H should be attached to the second carbon, and Br to the third carbon, and for the minor it will be vice versa. So we will proceed to mechanism for the formation of major product. Okay, here we have two steps, which is step 1 addition of electrophile, and step 2 formation of product from carbocation. Okay, here we look at the HBr. Okay, for HBr, H is more electropositive compared to Br. Br is more electronegative. So the bond between HBr um, will be will be attacked to Br because um, it needs one electron from the bond to be more stable, and the double bonded here between carbon will be attacked to H plus. Okay, and this reaction to break this HBr slow. It will be slow, and this one will form carbon with carbocation. So then step 2, formation of product from carbocation. Okay, here for Br minus will be attacked to the carbocation, and this mechanism should be in fast direction. And this one will form 3 bromo to methyl pen to ene. Okay, that's all.
Alright, now we are proceed to the task B, which is ion alkali component. So our group are choosing the grapefruit, and the functional group present is in the famous name, which is tartaric acid. But for the IUPAC name, which is 3,2-dihydroxybutanoic acid. So related Quranic verse is from Surah Al-Abasa 80:28. Bismillahirrahmanirrahim. Wa inaban wa qadba. For the translation is as well as grapes and greens. So for the introduction, in a grape there are tartaric acid, which is an organic compound containing more than one functional group. Under IUPAC naming rules, it is classified as carboxylic acid since the COH final group is more important in the hierarchical classification than the hydroxy group that are also contained with the molecule. So the structure is shown above. So you can see the structure, and the IUPAC name is 2,3-dihydroxybutanoic acid. So the composition of the plant is 400 gram serving. It will provide us 69 kcal energy, 0.16 gram fat, 0.72 gram protein, 18.1 gram carbohydrates, 15.48 grams sugar, 191 milligram potassium, and 220 milligram phosphorus.
Okay, as we know, Allah Subhanahu wa Taala has created plants and mentioned in Al Quran about grapes. Okay, so which favor of God you deny? Okay, here I will talk about the benefit of of grapes. Okay, as we know, grapes are good source of potassium. Potassium, a mineral, helps balance flow in our body. This can help bring down high blood pressure and lower your risk of heart disease and stroke. Most people don't get enough source of potassium, so by eating grape, this one can help fill the gap. Also, grape seeds are rich in vitamin E. Vitamin E is a good antioxidant for our body, so it will help our skin stay smooth and hydrated. Other compound in grape may help prevent and increase blood flow to your scalp for healthy healing. So reaction for the tartaric acid. Common esters of tartaric acid are diethyl tartarate and dibutyl tartarate. Both are made by reacting tartaric acid with the appropriate alcohol, ethanol, and N-butanol. In the reaction, the hydrogen of the COOH group is replaced with an ethyl group or butyl group. For ethyl group, we know it we know it as diethyl tartarate butyl group and dibutyl tartaration. Okay, that's all for reaction tartaric acid with alcohol.
Okay, that's all from us.
Thank you for listening.
Bye.